Disinfectants are affected by whether or not a surface has been cleaned already. So the more dirty or the dirtier a surface is, that can influence how effective a disinfectant such as bleach would be. The presence of organic materials, such as the presence of fecal material or blood or pus, all those things can influence whether or not a disinfectant will work to its optimal performance. The bioburden, which essentially is the different species or the mass quantities of microorganisms that might exist on a surface that's trying to be deconned, and then the concentration of the disinfectant is also a big factor affecting whether or not the disinfectant is going to work. Contact time means how long the disinfectant has to sit in order to kill the microorganism once it's come into contact with the microbial cells. So sometimes if you read the instructions on something as simple as a container of bleach, it'll tell you let your materials being deconned soak for about 30 minutes or so to give the product time in order to do what it's supposed to do, which is to control the growth of microorganisms. The physical nature of the object being disinfected can also influence whether or not the disinfectant will work. And then, of course, as we've talked about already, temperature and pH play a big factor as well in determining if disinfectants are going to work as they should. Chemical agents that are used to inhibit the growth of microorganisms, there's some specific properties that these agents need to have in order to make them the ideal killing or antimicrobial agent. One thing is that they should be able to target a number of different microorganisms. So there should be a broad antimicrobial spectrum in which the agent will operate on. The agent needs to be fast acting, which means it needs to do its job and it needs to do its job quick. And the organic matter, if any, is present where the microorganisms are that are trying to be deconned. They should not influence the disinfectant to prevent it from working. We don't want our chemical agents to be corrosive or harmful to humans, so we want to make sure that they're non-toxic and non-corrosive. And then you should also have a chemical agent that's going to leave behind some residual properties, so that way it can prevent microorganisms from colonizing that particular area that's being deconned. The chemical agent should be soluble in water, as well as be very easy to apply to the surface being deconned. The expense of the product needs to be cheap, relatively easy to prepare. And then the agent should also be odorless or be stable. So that way the product will be, so that way the product will be able to be used at a suitable concentration to influence the growth of the microorganisms trying to be killed. And here is kind of an outline that has different ingredients listed on it that are typically known as antimicrobial agents, such as ethyl alcohol, chlorhexidine, iodine. These three particular active ingredients are applied to a lot of antiseptics and disinfectants that are out there. Most of these are going to be antiseptics, so that means they're safe to go on the skin. And in the diagram, you can see what types of things are killed by them. So alcohol is great because see how it kills a wide variety of microorganisms, from envelope viruses all the way to all the bacteria, fungi, and the mycobacteria. But then you can see where the red is that there are some organisms that aren't killed or influenced by ethyl alcohol, such as protozoans or spores. Spores don't really have any effect from the alcohol. Chlorhexidine is really great. It kills viruses as well as gram-negative bacteria, some fungi, non-envelope viruses, mycobacteria, but doesn't do anything for protozoans or spores. And then iodine kills gram-positive bacteria, but not gram-negative bacteria as well. It kills gram-negative bacteria, just not as well. And then there's also fungus that are impacted by iodine. And non-enveloped viruses, protozoans, and spores aren't infected by them. So antiseptics are great to be used on human tissues, and they're effective because they reduce the number of microorganisms on the surface of the skin without getting too deep into tissues. Antiseptic soaps and scrubs are used by healthcare personnel to remove organisms lodged in pores or folds of the skin. So it's in these pores and skin folds where you can have the harboring of some microorganisms. So kind of think about that when you're working with patients once you start doing your clinicals. We just kind of want to touch on briefly inhibiting the growth of pathogens in our kitchens. Food, we know, provides a great nutrient resource for organisms, and so we want to make sure that food doesn't spoil. We want to make sure that we don't want to eat anything that has been spoiled. So a lot of stuff that's bought from the grocery store that ends up in your refrigerator can possibly contain samples of E. coli, Salmonella, Campylobacter. These are organisms that cause a lot of gastrointestinal complications to somebody who ingests them or ingests food that hasn't been prepared properly. And a lot of times, the products that we buy are going to be contaminated with these sources. Now, when we prepare them adequately, then you are less likely to contract these organisms because they can be killed by cooking your food properly. So you'll be eating dead cells, but these cells aren't viable. So because they're dead, they're not going to harm you. So when we handle foods before we cook them and we don't wash our hands, we may end up transmitting what's on our hands from the food into our own bodies in some form or fashion. Or you may contaminate different kitchenware that hasn't been washed properly. So the best way to control and inhibit the growth of pathogens in the kitchen is to make sure that you're aware that it's possible for you to come into contact with an organism that can cause you infection or a lot of pain that could be avoided by taking the necessary precautions, such as remaining aware of pathogens when preparing foods, washing your hands, clean plates, clean countertops, and make sure you wash everything with hot soapy water, because it's really the scrubbing effect that helps us to keep our dishes clean and helps us from getting sick through possible infection of microorganisms. Using antimicrobial, antibacterial kitchen sprays is kind of controversial because you don't know what kind of chemicals are included in those particular sprays, and so they can cause complications for you. But just be aware and figure out what works best for you and a very safe, manageable way to control the growth of bacteria. So antibiotics have taken a lot of flack because there's a lot of controversies that are surrounding them. 40% of antibiotics made in the U.S. are used in animal feed, and this helps livestock, essentially, to develop a better immune system. But what happens is that microorganisms are starting to resist the antibiotics, and they're starting to survive and become resistant. So as these drug-resistant organisms are starting to develop, it becomes a problem because now we don't know how to treat them because they've already been exposed to the antibiotics we would use to get rid of the bacteria. And we need to find more effective ways to figure out how to reduce giving antibiotics to livestock that we then go and eat. So the animal feed that's used is pumped full of antibiotics, which can do numbers on the host organism that's eating it. But it can also disrupt the organism's normal flora, as well as provide more complications to us because these microorganisms we're trying to kill are becoming resistant. We also want to use antimicrobial agents to prevent kind of transmission of bacteria or pathogens from inanimate objects. Kids in particular, when put into daycares, it's kind of like a smorgasbord for bacterial or viral infections. And the reason for that is because there's kids playing with lots of toys that get shared, and that sharing, those toys don't get deconned. In a kitchen setting, cutting boards, some hand soaps, as well as other household products, all of those can essentially harbor some microorganisms. And so what happens is these antimicrobial agents that are put in these particular products, they cause the microorganisms to adapt, and the microorganisms adapt, and the ones that do go on to produce offspring, and then they survive. And so this is how resistance is generated. So one of the things that we kind of want to put out there is kind of the idea is, how should we go about getting our children's immune system to develop properly? Like, is it okay to expose children to different microorganisms, different viruses to help build their immune systems, or should we keep them in a bubble and not have them do any exposure? Well, obviously through your study you kind of find the conclusion that we definitely need to have a nice medium, as children need to be exposed to certain pathogens in order to build immunities, because without those immunities, then those children are going to be highly susceptible to something much more dangerous when given a chance. So I'll leave that kind of food for thought, and I think what I'll do is kind of post this in the discussion forum, and see what kind of comments we have and discussion can be generated from this. Alright, well, thank you for listening, and good luck this week on your upcoming exam. So as always, if you need anything, please make sure you contact me. Alright, have a good week.